some more testing on this generator setup, and I have a few things that are happening that seem to be a little backwards of what normally would happen. This generator, I'm still using the coil from before in my previous video, 1400 turns, the Bifilar bucking coil, and I'm driving it with the 24 volt DC motor. In Tesla's patent, he talks about not using capacitors. Well, there was a reason for that back then, because they had a hard time making capacitors. But today capacitors are pretty readily available, so that's not a problem. Now there might be some configuration with the windings, the amount of turns or whatever, to be able to get a certain amount of capacitance, but I don't know exactly what that combination would be. But he talks about having a capacity to neutralize the self-inductance. Well, is he talking about using two wires so the one wire neutralizes the other, or is he talking about this coil neutralizing the self-inductance of a single wire coil, so the two used in connection with each other? And that's what I'm seeing in this generator setup, that there's something going on there with the transformer that I'm using. So I'll show you a diagram of this setup. The generator I'm using in two directions. Basically, the center tap of the Bifilar coil, I'm driving two LEDs in an AC configuration. They're 10 watt each, 12 volt LEDs. And then the other part of the Bifilar is going to drive this Bifilar primary on this transformer. Now first, I'm going to be running it without the capacitor in the middle of the Bifilar primary, and then we'll have a look at the difference with the capacitor there and how it affects the generator. So what I have here, got the LEDs here, and then the transformer, which I have my amp meter taped to. That's the primary, and this knife switch right now is set for no capacitor in the circuit, and I'll switch it over here to engage 33 microfarad, I believe. Yeah, 33 microfarad capacitor. Right now it's about 250 milliamps coming out of the generator, and you can see the generator voltage here. That's what's coming out of the generator. I don't have a meter connected up on the LEDs, and there's the volts going to the secondary of the transformer. This light kind of messes with my camera. Alright, so now I'm going to engage the secondary light, and you can also notice what happens to the amps in the power supply. Everything's all normal there. The secondary load increases power going in to the generator and also through the primary. The other thing about this is, with the open secondary, there's current still flowing through the primary of the transformer, and you can see my LEDs are lit on the other half of the generator, going in the other direction. Now if I disengage the transformer, You see it speeds up, so there's no load. So we do have a drag on the generator. But now I'm going to put the capacitor in. And I got 350 milliamps roughly going through the generator circuit. And that's got 13.5 or 13.6 volts coming out of the generator. Now watch what happens when I turn on the secondary. The amps drop. The power in from the supply drops 100 milliamps. And the generator speeds up. Also, the volts of the generator increased. The volts drop back down again on the generator. So it looks like the self-induction of the single wire secondary is somehow going back to the Bifilar coil for the primary and assisting the generator. And it's about 100 milliamp drop on the power in. Now if I hook this onto the LEDs, there's very little change on the voltage going across the LEDs. I got about 8.9 without 9.2 volts at the LED, so there's not much of a change there. Thanks for watching.